So let's get started talking about inequalities. Thanks for joining. I just heard someone else log in. We're going to be talking about inequalities for a few minutes. So inequalities are very similar to equations in that they still follow the rules of all equations. You still do opposite operations and your goal is still to get x by itself. So when you're solving an equation, you look at whatever math operation is going on and you pick the opposite to do so that you can get rid of it on one side and move it to the other. So if this says x plus 5, what opposite operation should we use to move it to the other side? Subtract the 5. We want to minus the 5. You can write it on both sides, or some people prefer not to have the clutter and just say minus the 5 on one side and cancel it out. So this is our solution basically, but what's different from equations, inequalities are a group of numbers. Any number bigger than 7, remember this symbol means greater than, and I guess I should have started with what does each symbol mean? Less than is when your pointy part is facing to the left. To me it looks like a sideways L, so that's how I remember less than. Less than or equal to has a line underneath. Greater than, the open part is on the left side this time. And greater than or equal to has the line underneath again. So this one is just all numbers bigger than 7. So we can have our answer written like this. This is the kind of algebraic format, but we can also draw a picture of it. You can draw out a number line. And the number line, we can draw a picture representing all the numbers bigger than 7. So greater than means we don't actually include the number 7. 7 is not included. So when there's no line underneath, that means we use an open circle at that number. So open circle, you have no line under the symbol. Closed would mean actually include that number, and that means we do have a line under the circle. Or sorry, line under the inequality. So right now we have an open circle because there is no line on this symbol. We also need to know shading. This was greater than, all the numbers bigger than 7. So do you think greater than will mean shade to the left or shade to the right? And you can just type your answers into the chat box, or if you want to unmute your microphone, you could say your answer out loud. Do we think greater than means shade to the right or shade to the left?
Is it to the right?
Good. All the numbers bigger than 7, 8, 9, 10, those are all bigger than 7. So we shade to the right. So you have to pick between open or closed circles, which we had to pick open for this symbol, and then shading to the right or to the left. So to the right is any version of greater than. Greater than or equal to means shade to the right. And less than or equal to, that means shade to the left. So the symbol told us two things. Open circle, shade to the right. And every symbol will tell us two things. So let's look at another problem. So with a problem like this, now we've made it so we have more opposites to do. Our opposite operations. We always start with this plus or minus piece first. So this -3, we talked about with the problem before, when it was +5, the opposite was to subtract. This time with our -3, the opposite is to add 3. So doing that opposite, now we have another opposite to do. The opposite got rid of the 3. We did 11 plus 3 to get the 14. Now we have this number next to this letter. The 2 next to the x. The actual math operation that's going on, they don't show. Up here, they showed us we're doing subtraction. Right here, they don't show us that this is actually doing multiplication. So even though it's not shown initially, once you identify, okay, I know a number touching a letter, that's actually multiply. Now we need to do the opposite of multiplication. So what's the opposite of multiply? Just want to say thanks for joining. We're talking about inequalities for a little bit. We've been solving this inequality. We did the opposite of subtraction, which was to add. And now we're trying to decide what's the opposite of multiply. So opposite of our multiplication will be to divide. When we do the division, just like these opposites canceled, -3 and +3 canceled, those opposites cancel. And on the other side, that's where we actually do the division. 14 divided by 2 is 7. Now, if there get to be any numbers too complicated to work with, or if it was 15 divided by 2 and we're going to get a decimal, feel free to use a calculator. I often just search for Google Calc, and then I have that calculator pop up immediately and just start using it in the web browser. Or you can use a cell phone calculator or buy a handheld calculator. So anytime, again, this could be the answer. Sometimes the answer is represented in this algebraic way, but you could also be asked to provide the answer as a number line, as a drawing. So the symbol here, the less than or equal to, will tell us two things. We have to decide between an open or closed circle and we have to decide between shading to the left or to the right. So what do you guys think? Will this symbol tell us to have an open or closed circle? It's less than or equal to. I'm going to go back a page to where we wrote the information down. Our symbol was less than or equal to, so does that mean open or closed?
Closed.
Very good. Closed circle. Good. Thank you. So closed circle, that just means we fill it in. So how about our shading? To the left or to the right? Good job. To the left. So you'll notice I put a similar problem up here. That's because there's going to be one slight difference, and this is again where inequalities will be different from equations. Equations, we'd do this exact same process till we got x equals 7. We'd be done. Inequalities, we still do our same opposites. Opposite of minusing 3 is still plus 3. Nothing's changed so far. Opposite of multiplication is still division. And since our opposite is the dividing part, we keep the negative sign. We're not doing the opposite of negative, we're doing the opposite of multiply. So still doing all the same opposites so far, but here's where the change comes. Instead of a less than or equal to symbol now, anytime you divide by a negative or multiply by a negative. So we don't care what's happening with the 14. We don't even care about our answer. We don't care if our answer is positive or negative. Anytime you divide by a negative number, you have to flip the inequality symbol. And it's really easy to forget because we don't use it very often. The reason we have to do this is because on the number line, the negatives work differently than the positives. Here, a -5 is actually smaller than a -1, but it looks like the number 5 should be bigger than a 1. Negatives, those big numbers, are actually the smaller, because smaller on the number line is further to the left. Whereas over here, 1 would be less than 5. So it kind of switches. If we write them in the same order, if I put the -1 and the -5, you have to change that inequality. So you can't forget to now flip the inequality symbol anytime you divide or multiply. I'm going to add that in. Most of the time it will be dividing by a negative. So for drawing our picture, I'm going to have to relabel the number line. I was just trying to show the difference between the positives and the negatives, but we can't draw our actual solution if we don't have a -7 on the number line. So again, it's not going to change a whole lot from what we did the first time. We still have a closed circle, and we still got a similar answer. -7, not that different than +7. But now, since it's greater than, our shading will change direction. Change to the right instead of to the left. So that little rule you can't forget, because it can mess you up at the end of the problem. So that was our first 15 minutes. I do have one more inequality problem if we get to it, but this is also supposed to be about what are you having trouble with. So is there a particular topic you guys would like to talk about for a little bit?
Elimination.
Elimination, okay. That is a tough topic. So elimination problems is when you're working with systems of equations. Now, since I am taking random questions, I'm making up random questions myself. This may not work out super nice. I will try my best, but we might end up getting some decimals and stuff because these are hard problems to just make up off the top of your head. So elimination problems, we have two variables. Our goal is to get an answer for x and for y. So what we want to look for, and this is the easiest version, we'll go over a more difficult version next. What we want to look for is any of the variables that are already different signs. Our y variable has one negative and one positive. And if we're super lucky, already the same number. Thanks for joining. We just got one more student in. Right now we're talking about elimination. I'll write it up here so we can see it. So we're solving for x and for y. So on the super easy problems, if we find two variables that have different signs and the same numbers, if there's no number written in front, we do know that these are technically coefficients of 1. You can add these together. Again, this is the easiest version. We'll do another version where we have to do a little bit of work before we can add them together. So when we add these two things together, we add the like terms only. The x's combined together, the y's combined together, and the answers on the right side add together. So 2x plus 3x is 5x, negative 1y and positive 1y. The reason we liked this setup is because negative 1 plus 1 is 0, which means we don't even have to write them at all anymore. 0 makes those go away. And that's our ultimate goal with elimination. We want those to go away. Then we add the other side, 12 plus 13 is 25. And now we just have a regular equation to solve. I'm going to put it closer together. If we have 5x equal to 25, what opposite do we do to get x alone? So someone says x is 4, you're really, really close. I think you had the right idea. Double check your 25 divided by 5. The opposite would be to divide. 20 divided by 5 is 4. 25 divided by 5 is 5. And it's super common. One of the killer things with math is just looking for small things that your brain just kind of twists around. You'll notice me make mistakes all the time. It's just nothing that ever goes away. You just have to watch out for those little details and be like, oh yeah, I knew what 25 divided by 5 was, but my brain just wanted it to be 20 divided by 5 for some reason. So now we have part of our solution. X is 5. That's half our answer. To get the y value, now we go back to the original equations we have. I usually just pick the top one. It doesn't matter which one you use. So I'm picking the top one. We found x, so we're going to plug x in. And remember, a number next to a letter is multiply. So 2 multiplied by 5 minus 1y equals 12. And now we have to do solving for this equation. So you do have to simplify first. 2 times 5 is 10. And now we do our opposites. It is in a little bit of a weird order. Normally we have the number over here, like we'd have y plus 10. So when we pick this opposite, don't be fooled by the minus sign. The 10 is not doing any subtracting. If there's no sign in front of a number or letter, it's positive. Just like up here, this is a positive 2x or a positive 12. So that's a plus 10, which means our opposite is actually to minus 10. Don't go by any signs behind, always go with what's in front. Then we do the subtraction, and just like we had to divide to solve for x, we divide to solve for y. Again, our opposite is the division, so you do not change the sign of the 1. You keep it negative because the opposite is doing the divide. And a positive 2 divided by a negative 1 is a negative 2. So that's your final answer. Both of those together. It can also be represented as a coordinate. Always put x first. So it could be written as 5 comma negative 2, or you could just have them written separately. So that's the easiest version of elimination. That's if you get super lucky, super nice problem. Most of the time, that's not going to happen. So again, I'm making these up off the top of my head. This one's a little harder to do, so we may not get a nice answer. So when we have a problem like this, we still want to try and find any variable that doesn't have a coefficient, that the coefficient is just 1. So what variable on this either equation only has a coefficient of 1? There's no number actually currently written in front of it. X. Good. So this coefficient, we want to make it match the other coefficient but have the opposite sign. The reason we like just the x is because when it's a 1, it's easy to figure out what to multiply by. We have to say, well, what are we going to multiply 1 by to get it to be a -3? We want it to match this number but be the opposite sign. Well, that's just going to be a -3. 1 is nice to multiply by because 1 times anything is just the thing you picked. So we want to multiply this whole term times -3, but we can't just change one thing. Equations have that equal sign for a reason. If we change just a part of it, it's not equal anymore. So we have to multiply all of them by -3. So I'm going to rewrite the first line just because we will still need it. And then we actually do our multiplication. 1 times -3. Remember the rules for multiplication is positive times a negative equals a negative. But if they have the same sign, negative times negative is a positive, or positive times positive is a positive. So +1 times -3 is a negative. -4 times a -3 is a positive 12. And 12 times the -3 is a -36. Once you have that worked out, now it's the same process of what we just did. Exact same. We add together in columns. All the like terms add together. So the reason we multiplied by that -3 was to make these opposites and have them disappear. -3 and a +3, 3 minus 3 is 0. Then we combine together. 5 plus 12 is 17y. And 8 plus a -36, I'm going to pull out the calculator for this one, is -28. So almost always these come down to then division. We're going to divide both sides by 17. This is not going to come out nice, so I'm going to have to pull out the calculator for this one. -28 divided by 17 is -1.647. So I think in the assignment, you're not going to get weird decimals like this. If there is a decimal, it'd be like -1.5. It'll be a little nicer. But as I said, making these problems up can be a little bit difficult. So that's only part of our answer. Remember, our ultimate goal is to find x and to find y. Right now, we only have y. We have to go back in and find x. So again, I usually just take the first line. This time, though, we're not replacing x. We didn't solve for x. We are replacing y. We simplify this multiplication part. 5 times -1.647. -8.235. Since the answer came out negative, I don't need a plus sign anymore. We just use that minus sign. And now we just do opposites again. What's our first opposite we should do? Good. Add. So 8 plus 8.235 will be 16.235. And then our last opposite with these, always going to end up with that division. And again, I can't do this in my head, so I'm going to have to type it into the calculator. 16.235 divided by 3, 5.412. So these are our two answers, or you can write it as a coordinate. So any other questions about elimination then, or did that help answer all your questions about that process? Good. Okay, so next topic is sequences. Sequences is in the end of semester 2 or quarter 4, depending on where you're at. It also comes up in algebra 2. They're seen a lot. They're pretty straightforward for the most part, but it still helps to know, what pattern are we looking for? So sequences, they basically give you a list of numbers, and they say, well, what's this pattern, and can you find an equation for that pattern? So on this pattern, we're adding the same number every time. So when you're adding, this is called an arithmetic sequence, which just means add. So what number are we adding every time? 6. Good. So knowing that information, that is called the common difference. It's just the number you're adding every time. And we could use it to do a couple of things. We could find the next term. We could add 6 again and know that the next term is 28, or add it again, know that the next term is 34. But let's say we wanted to know the 30th term. You could literally keep writing it out over and over again, but that's a giant pain. That would take forever. So looking at our list, the first number is called the first term. Second number is the second term, so on and so forth. And we need to know this in order to write out the actual equation. So this equation is the term you're looking for, that answer you get. This just represents, this is the answer you're trying to find. The a sub 1, they put a little 1 underneath, not to say anything mathematically. We're not adding it, we're not multiplying it. It's just to say this is the first term. The 1 is our first term, which we've already identified as a 4. The n represents whatever term we want to find. And then d stands for the common difference. So if we just want the equation itself, then we don't replace the n with anything. We say n minus 1, 6. This is called the explicit equation. It will tell us any term we want to know. So that could be an answer they're looking for. I'm trying to cover all the possible questions that might be asked. So it might just ask you to find the next term or the next couple of terms. You might need to find this explicit equation, or if they said find that 30th term, that's where we actually plug in the number. So this has to follow that order of operations. There's certain orders you have to simplify numbers in order to have it come out with the correct answer. And you'll probably remember PEMDAS. It's seen in a lot of math classes because it's used a lot. And this says that when you're simplifying anything, do the parentheses first. So we have to do the 30 minus 1 first, which is 29. So we've done parentheses. If there are exponents, we would do exponents, but we don't have any. So next comes multiply, divide. The MD actually goes together. If you have a whole bunch of multiplication and division, do it all at once, from left to right. In this case, we only have some multiplication. 29 times 6 is 174. And then addition, subtraction is grouped together again. If there's a whole bunch of addition and subtraction, just go left to right. In this case, we only have one set of addition. So that's 178 for our final answer. So the 30th term is 178. So that's all the questions you could ask about an arithmetic sequence. Again, that means an adding sequence. So you can also have geometric sequences. Geometric sequences are when you're multiplying by a number every time. So what number are we multiplying every single time? What do we multiply 3 by to get 6? And 6 by to get 12. Good job. 2. So instead of being called common difference, this time we're called common ratio. Again, we can answer the same types of questions. Maybe they just want the next term. If we want to multiply by 2 again, we can get the very next term, which is 48. Or we can be asked to find an equation, or we can be asked to find a certain term. These ones, they won't be as big, like we would find the 8th term. With multiplication, multiplication can get really big really fast. So if they even said to find the 20th term, it's probably too big. It'd be just, like a trillion or bigger. So these stand for some of the same things. A of n, this is just a fancy way of saying this will be your answer. A sub 1 is still your first term. R is now your common ratio instead of your common difference. And N is the term you're looking for. Any questions? Someone unmuted, so I just want to, do you have a question or was that an accident? Okay, must have been an accident. So, if we want the explicit formula, we plug in the first term and the common ratio. So what's our first term on our list? 3. The very first number written is considered to be the first term. And then technically this is multiply. It's not written usually in the formula. I like to add it in just so I remember every time this is multiply. We found the common ratio is 2. And then if it asks for the formula itself, we leave it as n minus 1. So if you're asked for the explicit formula, we stop here. If you're asked for the 8th term, then we plug 8 in where we see n. And you can even write it as a of 8. This notation, it looks really fancy and weird, but it's just saying plug in 8. Plug in 8 to find the answer. So order of operations again. It says to do exponents first. This exponent is kind of weird because there's 2 things already there. It's kind of like parentheses. Even though they don't have parentheses actually visible, you do have to take care of that first. Do the 8 minus 1 first. If you have a pretty fancy calculator or you use this Google calculator, you could type the whole thing in. You use this XY button to make it an exponent. And you just have to leave it in the box. Oh, see how it took me out? Let me see if it's even possible to. I thought it would let you, nope. So you do have to do that minusing yourself so that you get the 7 that goes in here. So let's still take it piece by piece though. You could type the whole thing if you're comfortable with that, or you could say, I know exponents come next, and we can just do 2 raised to the 7th. Some calculators don't use an XY button. Some calculators use a little triangle type piece. Or if you just can't remember how to type it in, you could do 2 times 2 times 2 times 2 times 2 times 2, 1 more. So it just depends on your level of comfortableness with the calculator. So that's 128. And then we do the multiplication. 3 times 128. Oops. 2, 8. Did it again. 2, 8. There we go. 384. So the 8th term is 384. So these were all nicely set up sequences. What if it's like a list of decimals? Something like this, it's not as easy to see common ratio or common difference. We don't even know which one this is. We don't know if this is add or if it's multiply. You can kind of get a guess by looking at it. 2.7 going up to 12.9, that's not a huge jump. Usually the common ratio, you're getting big really fast. Those geometric sequences, you end up with some really big numbers or possibly some really small numbers. Like if you kept dividing by a number, you'd get really small decimals. So this is probably add, but what do we know? What's 2.7? What do I add to that to get 6.1? It's harder to tell. So a way to find a common difference, if it's not as easy to see, is to do the second term minus the first. So which one is the second term on our list? Good, 6.1. Minus the first term, so minus the 2.7 is 3.4. So that's just another option of how to find the common difference if it's not clear just by looking at it. And good, someone else got that correct. Common difference as well, 3.4. So if we had to multiply one, it's a similar idea to find the common ratio. So you'll notice these decimals are getting pretty small pretty fast. So probably it's a geometric sequence. You can try and find the common difference, but if you're not sure, just double check. So like on our first one, we said, well, 2.7 plus 3.4 is 6.1. I'm going to double check and make sure that 6.1 plus 3.4 really does give me 9.5. If it does, it's for sure arithmetic. If it doesn't, then it's probably geometric. So geometric wise, if you want to find the common ratio, instead of second minus first, it's second divided by first. Notice that we're using the opposites. The arithmetic sequence is all about adding, and we do second minus the first to find the common difference. Geometric sequence is all about multiplying, and we do second divided by first to find the common ratio. And that's something, again, not something you can really do by hand. It's technically possible, but it's a waste of time. Uh-oh, can everyone still hear me? Shoot. Somehow I got logged out. I just want to try and sign back in and make sure. Okay, everyone still hear me? I thought I had a little technical error. Okay, perfect. As long as you can still hear, that is great. Okay. So 1.25 divided by 5, 0.25. So this time our common ratio is a decimal. 5 times the 0.25 gives you 1.25, and so on and so forth. Okay, so that covers our sequences. Now it's open to any questions you guys have again. Any topic at all that you want to talk about. If no one has a topic, I can pick other topics. We still had some inequality stuff to talk about. Radicals, okay. So radicals, that's the fancy name for taking a square root. When you take the square root of a number, you're basically trying to figure out what number multiplied by itself 2 times equals 25. So it can't just be any numbers, you know, technically 12.5 times 2, that equals 25. It's got to be the same number. So the square root of 25 would be 5, because that number multiplied by itself is 25. If there's no nice number, like if we just even move this up 1 to 26, it's a big long decimal that again is something you can't do by hand. Calculators are super important in math. You need them a lot. So on the calculator, usually there's a check mark button to say this is going to give you a square root, and then you just type in the number and get your big long decimal. Technically, this decimal keeps going, but the calculator can only show you so many digits. There's something after the 9 and it just goes forever. Usually you'll be asked to round, like if we want to round this one to the nearest 10th. Would that 0 stay a 0, or would it go up to a 1? This is the 10th spot. We have to decide how to round it. go up to 0.1. The 9 next to it is what tells us. That tells us because it's between a 5 and a 9 that we round up. So the 0 goes up to 0.1. So there's kind of a lot of things. I wanted to give a basic definition of what a radical is. You can have to maybe simplify radicals. Technically, this simplified form would be 2 square root 10. You might have to add radicals. Is there a more specific topic? Because technically I can't add that. Let's give them. Because I can pick one. Simplifying is used a lot, but just to make sure I'm covering what you want to know, was there a specific radical topic, or is simplifying them a good enough start? Multiplying and dividing. Okay. When you multiply radicals, they're kind of similar to fractions. If we had the fraction negative 3 over 10 times 5 over 2, we multiply top to top and bottom to bottom, because numerators multiply together and denominators multiply together. When you're multiplying radicals, the number in front, this coefficient, can only multiply by the other number in front, that coefficient. If there was no 5 there, we would just bring it down. We wouldn't have anything to multiply by. And the numbers under the radicals can also multiply together, but you can never mix that up. You can't do negative 3 times 2. This one doesn't have a radical, but the 2 is under a radical. So I kind of think of it almost as like things, not exactly like terms. But then you just do your multiplication. Negative 3 multiplied by 5 is negative 15. And 10 times 2 is 20. Now that will not be your final answer. They always want you to simplify. So when you're simplifying your radicals, that means we need to break it down using a factor tree. So when you factor tree, you look for any two numbers that multiply to be 20. We always want a factor tree under the radical. We don't care about that 15 in front for a factor tree. So what are any two numbers that multiply to be 20? Two and 10, that's one answer. Maybe someone else thought 5 and 4. Doesn't actually matter. Pick whichever one you think of first, because then you keep breaking down if it can. The 2, the only thing that multiplies to be 2 is 2 times 1. It's called a prime number, so we don't break that down any further. We don't care when it's 2 times 1. The 10, we can do 2 times 5. So we have 2 times 2 times 5. That group of 2, if we go back to our definition of a square root, we were looking for numbers that multiply by themselves. Well, 2 times 2 is multiplied by itself. So usually what I do is actually multiply them back together, but then each part gets its own square root symbol. 4 gets its own square root, 5 does. And the 15 just comes down. We haven't done anything with it. But then we can actually take the square root of 4. The point of the factor tree was to break it down in such a way that at least part of it can be taken as a square root. Square root of 4 is 2. So now that the 4 is no longer a square root, we took the square root, that can actually combine together. They're both not under the square root anymore, so they can multiply. So negative 30 square root 5 is your final answer. Did you need to see any problems with variables in them? There's often problems where you have to simplify using a variable inside the square root. Okay. So let's get some variables involved. Okay, so it's the same general concept of anything outside can multiply, anything inside can multiply. 2x is outside, there's not anything else outside, so that just comes down. 6 multiplied by 12, when we multiply with variables, we do the numbers first. 6 times 12 should be 72. Variable-wise, it's more like counting. If you have x times x squared, there's really 3 of them. 1, 2, 3, since x squared means there's 2 of them. Or if you remember the rule of exponents, you do 1 plus 2 to get 3. And then y times y, now there's 2 of them, so y squared. So again, same general concept. Now we need a factor tree. We'll get to the variables in a minute, but you still have to factor tree your number. We know 6 times 12 made the 72, so I'm going to start with that and keep going. So most of them are prime, but the 6 can break down one more time. So we have 2 times 2 times 2. Sometimes I cross them off as I go because it's hard to see when you get these bigger factor trees. Times 3. And then you can break down the variables as well. X to the third means x times x times x. And y squared means y times y. So that's our entire broken down factor tree, including the variables. So we still look for groups of 2. We have 2 2s with an extra 2. We don't circle that, that's not part of our group of 2. We have 2 3s. We have 2 x's with an extra x again. And we have 2 y's. So now let's multiply all those groups back together. 2 times 2 times 3 times 3 is 36. X times x is x squared, and y times y is y squared. And then we have leftovers. We have the 2 and the x that didn't get in any of the groups, and they get their own square root. So now we actually take the square root. I'm going to have to move up here because I ran out of room. Nope, we're taking the square root, so we don't want a square root symbol anymore. Square root of 36 is 6. Actually type it in though, 36. There we go, 6. And then this is the tricky part. With our variables, the square root of x squared is actually just x. Again, that definition of square root was what multiplies by itself. Well, the only thing that makes x squared is x times x. So the square root of x squared is x. Same thing with y squared. The square root of y squared is just y. So we get 6xy square root 2x. And then our final step is to combine anything in front still with multiplication. So 2 times 6 is 12, and x times x is x squared. Y didn't have anything to multiply by, and the square root of 2x is just coming down as part of our final answer. So that works with our variables. You also requested what happens when we divide. So when we're dividing, we don't like radicals in the denominators of fractions. This is not considered simplified because there's a radical down here. So they came up with a process called rationalizing the denominator. And it's kind of a weird process because most of the time you see, hey, I need to do an opposite. You know, there's something in the expression that tells you kind of what to do. This one, it kind of feels like we're pulling stuff from thin air. So when we rationalize the denominator, we want to pick something to multiply by, and we're picking a specific something so that it cancels the radical. There might still be stuff in the denominator, just not a radical in the denominator anymore. So with square roots, it's usually just the radical itself. We want to multiply by square root 2x. But just like equations and the elimination process, you can't only do it to just the bottom. That changes stuff. It makes it not the same fraction anymore. But if you also multiply it by the top, this is called a clever form of 1. If we had like 4 over 4, that equals 1 because 4 divided by 4 is 1. Even though this is bigger, there's variables and radicals involved, it's still something over itself. This whole fraction is 1, so technically we're not changing anything. Then we just multiply across. So radicals, you cannot combine a 5y that's not under a radical with a 2x that is. So you just write them side by side. But on the bottom, we can combine. 2 times 2 is 4, because they're both under radicals. And x times x is x squared. But we picked that thing to multiply by specifically because now we can take the square root. The square root of 4 is 2, and the square root of x squared is x. If the stuff not under a radical could simplify, if this had said 6y, we could do 6 divided by 2, then you would simplify. Nothing here simplifies, so that's just your final answer. Our whole goal was to not have any radical in the denominator anymore, and we accomplished that. So we're out of time today. Thank you for joining. We'll be having another one again in about 2 weeks, and they'll send out messages again when we're ready for our next session. In the meantime, if you have any other questions, feel free to send me a chat message. You can email me at April. Oh, I may not be your actual math teacher, so send your math teacher a chat message, or you can email me at aprilbarton@graduationalliance.com. If I am your math teacher, you can send me a chat, but there are a couple of math teachers, so I may not be your main one. Thanks for joining and have a great day.